All right, so in the last video, you learned how to find the center of dilation, and once you've found the center of dilation, you learned how to find the scale factor. So now let's actually learn how do we perform a dilation when we are given a center of dilation both at the origin and not at the origin. So we're going to do an example of both, and then you're going to try some on your own. So we're going to start with, we're on page 7, we're going to start with this first example. It says dilate by a scale factor of 1/4 if you know the center of dilation is 0, 0. So I'm going to mark my center of dilation in black, and I'm going to label my points A, B, C, D, and E. And so what I'm going to do is I'm going to write down how did I go from the center of dilation to A. And so to go from the center of dilation to A, I had to go over 8 and up 4. So I'm recording my horizontal and vertical distances. I'm going to do the same thing for B. For B, I also had to go over 8, but now I'm going up 4. For C, I had to go over 4 and up 8. For D, I had to go over 4, up 4. And then for E, I had to go over 6 and up 6. Okay. So then what this means is when I'm going to perform my dilation by a scale factor of 1/4, I'm going to take all of these distances and cut them, basically multiply them times 1/4, or if I'm multiplying times 1/4, I know that really means I can divide by 4. So then that means when I go to A prime, if I divide these by 4, it means I'm really going to go over, so if I divide these by 4, I'm going to go over 2, and then 4 divided by 4 is 1. And then for B prime, 8 divided by 4 is also 2. 4 divided by 4, oh, that's not 4, that should have been an 8 there. So that means I'm going up 2. For C prime, 4 divided by 4 means now I'm going over 1. And instead of going up 8, I'm now going to go up 2. For D prime, there we go. So for D prime, if I divide both these by 4, I'm going over 1 and up 1. And if I try to do 1/4 of 6 or divide by 4, then that means for E prime, I'm really going over 1.5 and up 1.5. So then what I'll do is I'll take these new horizontal and vertical distances and I'll plot them coming from the center of dilation, and that will create my new figure that is 1/4 of the size of the original. So for A prime, I'm going over 2, up 1. For B prime, I'm going over 2, up 2. C prime is over 1, up 2. D prime is over 1, up 1. And then E is right here in the middle. I can't even really write an E in there. And then I'm going to connect my points. And there is, sorry, that left side's a little sloppy. There is my new figure that is 1/4 the size of the original from the center of dilation being at the origin. Now, this work I showed right here, some of you may not need to write it all out like I did, but at least when you refer back to this, you kind of understand where these new distances came from. So you're going to try part B on your own. So if you want to pause the video and try it, see how you do. You can check your answer on the answer key. But we're going to scroll down and we're going to do one that is not at the origin. It's going to work the exact same way. All right, so for this one, we're actually going to do part B because part B is an enlargement, whereas the one we just did was a reduction. So for this one, if my center of dilation is 6, 4, so 6, 4, and I'm going to label my current or my original figure as A, B, and C. And so we can do the same thing that we did before. We're going to jot down, so for A, from the center of dilation to go to A, I have to go backwards 4, and I didn't go up at all. For B, I'm going to leave a space so I can do the primes. For B, I had to go backwards 4, and then down 2. And then for C, I have to go backwards 2 and down 2. So when I want to perform my dilation where my scale factor is 2, that means I'm going to take all of these distances and I'm going to multiply them times 2. So that means for A prime, I'm going to go left 8 and up 0. 4 times 2 is 8, 0 times 2 is still 0, but I'm going to go that distance starting from the center of dilation. So I'm going to go over 8, and then I'm not going to go up or down any. So there's A prime. For B prime, that's going to become left 8 and down 4. So I'm doubling the distances. So if I go over 8 and then down 1, 2, 3, 4, B ends up right here. Sorry, B prime. And then lastly for C, if I double C prime, I'm going to double these distances. So I have to go left 4 and down 4 from the center of dilation. So if I go left 4 and down 4, C prime ends here, and then I just need to connect my points. And so I created a figure that is twice the size of the original. And if I were to connect these points, I want to show this to you here. I didn't show it to you in the last example. But if I connect these points, see how they all form a straight line and they all intersect through that center of dilation. So what you're going to do is I want you to try A on your own, and then C and D are a little bit of a challenge. So if you're up for that, I want you to try them. Do know we're not going to give you any that are that hard, but if you're someone that likes a challenge and like to work with some fractions that are a little bit more difficult, I want you to go for it and try it.